I welcome those that have joined us, and hope this will be a worthwhile hour for you. Not sure how many of you were here for the first one I did last month, but this is a follow-up. So by my clock, it's time to get going. I'd say good afternoon. It's noontime here in California. I'm Rick Escalambre. I'm presenting this Thursday tech tip for Delphi, and I'm honored to do it. Last month we did EVAP tips and tricks before the smoke. This month and next month we're going to do EVAP tips and tricks working with EVAP monitor tests, part 1. And hadn't planned it that way, it wasn't announced that way, but I have enough material that we're going to go ahead and do a part 2. And I'll show you what's going to be in that one. And also it's being recorded, so Delphi should be sending you a link when we're all done. It usually takes a little time to get it rendered. So let's get the show on the road. Anyway, EVAP tips and tricks working with EVAP monitor test. What are we going to do in this next hour for Tech Tip Thursday? Part 1. We need to address fuel volatility. Short time on that because it's very critical to run an EVAP test. I've been working with EVAP since 2004, 2005 in there, and I've run tons of EVAP monitors. I hear constantly that they don't run, and that people don't worry about them because they're not required for a typical state inspection. There are some states, though, that if you fail for EVAP, then that monitor test must be complete and that flag must be flipped for EVAP to pass an OIS test or a state inspection test. But just in good practice, we want to run EVAP monitor tests if we can to verify or repair. Just that in itself is worth doing it. And so many times I've heard people say, oh, they don't run. I know depending on the part of the country you're in, there's times of the year where certain EVAP monitor tests will not run because the environment, the temperature, just is too extreme for EVAP to run. But now that we've gone to the key-off systems and the pump systems, the frequency with which they run is much better than it used to be. So today we're going to talk about make sure the vehicle's prepared. We're going to talk the difference between a series and parallel test. Series apply to EVAP monitors. Parallel monitors apply to things like catalytic converter and oxygen sensors. We're going to take a look at GM's EVAP systems today, and then running Nissan Infiniti EVAP systems. For you that are going to be around for part 2, here's what we're going to do next month. I believe it's October 23rd will be part 2. We're going to take a look at running Honda Acura EVAP monitor tests. They're different systems. Honda Lexus, we got 3 different systems with them. And especially here in the Pacific time zone, I'm sure we still have a lot of the Toyotas and Lexus out there with the early non-intrusive and intrusive systems. So you'll get a really good look at that, so you won't be hesitant to try and run one of those EVAP monitor tests. Ford has some unique things, pretty common stuff they do, but we'll address that. And also we'll look at leak detection pump systems. That could be your LDPs, that could be your key-off pumps. A couple ways we can go on that. And we hope to address, if there's time, to address some of the various service bay tests. We're going to look at a couple today, or one in particular today, so that you can see that if you know your scan tool and you get over the OE side of your scanner, you can go ahead and verify parts of your repair, if not all of your repair, in the service bay. Okay. So, reminder for you that are new, and some of you were here last time, this is my website. The link's on the top. It'll be on the last slide also. This is a free website. No cookies, no advertising. It's there for you, the technician, the instructor, the OEM, to really get a good look at the topics I have there. Since the last time I met some of you, or some of you first-timers, I should say, if you go through my website, there's a lot of stuff there, and there's a lot more coming. As it says on the right-hand side, I had a lot of summer travels this year, both conferences that I did and family travel, which was awesome. But now I hope to spend the next couple months populating the website. So the other thing I'm doing is it says new content on website. That's basically like a technical service bulletin page. Anything I add will have a date, what the topic is, and what the link is to it. So if you've been through my website and you want to check back, that's where you want to go to see what's new. And anywhere else you haven't looked at before, but that would be the main thing. So basically rlescalambre.net. And again, don't expect any follow-up. Don't expect any cookies dropped on your computer. This is 100% for you. There's a lot more information under more. There's industry links. to GM and Ford information that's awesome. Companies you might not deal with normally that you could find as tremendous resources. So just to take a look at that, not spend a lot of time on that. What are we going to do today? We're going to focus on the EVAP readiness flag. For you that are new, the EVAP readiness flag, basically what I call readiness flags, they're what we use for state inspections, and what we use to verify that the PCM has finished testing of these different non-continuous monitor tests. The catalytic converter, oxygen sensor, air fuel, heated O2, air fuel sensor, heaters, EGR, VVT, secondary air, and EVAP. When it says complete on your scan tool, that means that the system is done testing. Flat out. No matter what year it is, complete means done testing. But it wasn't until 2008 that it was mandatory that they had to say complete when they were done testing. Prior to that, pre-can cars, if the system did not finish because of a DTC or something, it could stay incomplete and you get a DTC. So 2008, complete just means if there's no mill, there's no DTC, pending or otherwise, that system is passed. So keep that in mind. Now, one of the other things about these monitors, I always say this, if you've ever done these, they can only flip to complete once per key cycle or once per trip. Well, I'm going to show you in a couple examples today. If the system is failing, the PCM may run the test a couple times to verify that it truly is a failure and they want to avoid any false failures. So they might run the test a couple times. So when things take longer or you see things happening that seem to be like something's going on, why isn't it setting it? It's because it's retesting it because it sees a possible failure. Now I'll take a look at it. We'll take a look at example down on one particular one today and one in the next class. Okay, so as I always mention this is our starting thing when we're getting in these cars. We want to know what the PCM sees. And one thing you want to verify when you get in this system is make sure that when you're looking at this, when they say not supported, which things like AC, secondary air, heated cat, that's pretty normal across the board. Secondary air could be supported, but the other two are not. AC and heated cats are not. But if you see not supported in any other ones, then you want to have a little red flag that somebody didn't get an aftermarket tuner and turn off the monitor test. So just keep that in mind. It's just a little tidbit of information. There's also more to this read and readiness flags. This is the history of it since last clear. There's also one called this key cycle. We're not going to get into that now, but the fact remains is we want to focus on running EVAP monitor tests today. Over the years that I've worked with this, not only with the EVAP machines, running the dynos, verifying these tests, what works, this is a good, solid, generic criteria for a thing we call vacuum decay. If you were with us in the last class, vacuum decay we addressed, but for you that are new, vacuum decay means we're going to use the engine vacuum through the purge valve up to the vent solenoid to determine if the system has what we would call a large leak. Some people call it a gross leak. I like to call it weak vacuum test, but I'll get into that as we go along. We use the engine vacuum. Even a couple of systems that have a key off system, they still use vacuum decay. Pump systems typically do not. They run their full checks through that and verify that the purge is working and the pump doesn't have a small leak. And if it doesn't have a small leak, it doesn't have a large leak. So let's go through this. It says a cold startup, which is defined as a 6 to 8 hour engine off period. That time frame came from documentation from Ford, but typically what it's saying is in normal temperatures, for a vehicle to get down to the numbers that we're looking at here, IAT and ECT within approximately 10 degrees of each other, under 122 degrees, a normal environment, that takes 6 to 8 hours. The reality is, whatever time frame it is, it must be 122, below 122. The 10 degrees is not a given. That's an average number that CARB put out that I've used for years from looking at a lot of cars, but I see some that go as high as 12, 13, 15 degrees difference. The reality is the startup temperature should be between 40 and 95 degrees Fahrenheit. We'll talk about the reasons why in just a little bit. Throttle position, the main thing on this is you can have it part throttle, medium throttle, heavy throttle, as long as you're not sloshing the tank. I'm going to show you today that there's one system, it's okay to slosh the tank. It might be advantageous to you to slosh the tank, which means accelerate, decelerate, trying to build up pressure in the tank. But all other cars in that system I'm going to show you, you want to maintain a relatively steady throttle. Otherwise, you will have create fuel volatility. You will have high FTP readings in the tank, and it may prevent the monitor test from running because they feel it's too volatile. It's not a good way to measure vapor. If it's just way too volatile, we needed a certain equilibrium for testing. Fuel level. I've seen as low as 12.5. I've seen as high as 87.5. Typically, if we use an industry standard, people say quarter to 3/4. That what I would tell you is a very common average. So the criteria I'm giving you, you don't really need to go look up. This is what I'm saying to you. You set up these conditions I'm showing you, most EVAP systems will run. Okay, EVAP monitors using a vacuum decay method begin testing. Typically, my experience, and you'll see a couple of them today, 140 to 170. We don't want it too cold where there's no vapor. We don't want it too hot where there's excessive vapor that could give us false failures or false passes. We want it in a temperature range that gives us a fuel that seems to be fairly stable and has vapor, it has liquid, and we can find those small leaks. The last thing on this one is vehicle speed is not important. I've seen them go as low as 30, 35. Some of the numbers out there are 40 to 50. Really what you want is a steady throttle, somewhere in the 35, 45 range, 40 to 50. That's not critical. But the key word there is it's not load dependent. So if you're you're on the road and you're trying to go up a hill or down a hill, that's not always the answer. If you're on a dyno, you could do it with the wheels just spinning. If you're hanging on a hoist and you feel comfortable doing that, you could just have the wheels spinning. It's just looking for a consistent throttle with the vehicle technically moving down the road. So this is what I call my generic EVAP monitor criteria. This will hold to a lot of cars with vacuum decay so that you don't have to go look this up. Okay, a couple things. Gasoline evaporates at ambient temperatures just like water, but it evaporates faster. When it's open to the atmosphere, it'll evaporate much faster. In an open container, gasoline evaporates and diffuses into the atmosphere. That's another reason why we have charcoal canisters on the car. That granulated charcoal is filled with millions and millions of pores. So the hydrocarbons that are in the tank that sit out in the sun on a hot day, they're going to expand. They have to go somewhere. So we keep them in the system and they're absorbed by the canister. If they're left in the container long enough, the liquid disappears. As we all know, if you left a gas can out on a hot day, it eventually evaporates. We don't want that whole thing evaporating. In a closed container, when I say closed container, think of your gas tank. The vapor can't diffuse away. So we're going to run our test when that system is sealed so we can see if we are holding that vapor in there. And we're going to use our fuel tank pressure sensor to let us know how it's doing. Some other manufacturers might use a switch, some use a motor. But the idea is we need to know that the system is staying pressurized within a given limit. Eventually, the evaporation rate equals the condensation rate, and you get an equilibrium where now you've got just the right amount of balance of fuel molecules and vapor, so that if we have a small leak, we can push that vapor out through the opening and find it with our smoke machine, our gas sniffer, whatever it might be. And the last part of this is temperature is critical to this. I'll show you later on Nissan how they do it and why they're so easy to run. Typically a cold start, the fuel is there's no vapor, it's heavy, there's no way to find leaks with a cold start. No, not a good time to test because it's just too cold. On the high end side, on the high temperature side, I've seen anywhere from 95 to 105 as being the limit for if the fuel tank temperature indicates that the volatility of fuel is exceeding 105 degrees, it's not going to allow the test to run. For most cars, they're doing that through the FTP. They're doing it through the fuel tank pressure sensor and the voltage that it implies. For the Nissan I'm going to show you later, they have a temperature sensor in the tank, and that's going to be the key to running Nissan EVAP monitors. The disadvantage of that is, because it's so temperature sensitive, depending on the environment you're driving it in, if it's a cool day, it would take quite a while to get that temperature up to where the system will test. And I've had them go on hot days where it only takes a matter of 15, 20 minutes, and I've driven them on cold days where you could drive for many miles before that tank will get hot enough to build up the pressure to do the testing. So we don't want to test it cold, we don't want to test it hot. That's why I said most EVAP vacuum decay systems begin somewhere between 140 and 170 degrees Fahrenheit. Okay, chart that I've used before and I use all the time is just to give you an idea when you're working with EVAP. There's different names, different terminologies. This will give you an idea what you're working with when you're looking at your fuel tank pressure sensor on your scan tool, or you have a a pressure gauge hooked up like this with a compound gauge that will read vacuum and will read pressure. If you notice this compound gauge is reading 0, that means we're at atmospheric pressure. The bottom one we're going to use in the next class when we test the Honda with the engine off to see that it's cooling into a vacuum with a key off system. If you have a car with a service port, this is very easy to do if you have a compound gauge. You can even just buy a compound gauge out there and set up an adapter to go to the service port, and you can hook that up to the car immediately after shutdown or before shutdown, and then shut it down and let it sit. And when you start to see that thing going like the bottom picture, you know that something's going on. That tank is cooling into a vacuum. And again, we can talk about that more as we go along. But this side over here is to let you know there's atmospheric pressure right there. It's 1 psi. Okay, 14 psi. That's psi. This is a half a psi, and that's typically what your EVAP machines put out. So if you're using a smoke machine, they're typically limited to a half a psi. We don't want to blow anything open. I don't mean blow it open in the sense of explosion, but we don't want to overpressurize the system. I drew this line. It's a typical vacuum decay pull down number. I've seen lower, I've seen higher, but this is an average of what we want to pull the system down to when we're testing it. And we'll see this as we go through the slides today. Okay, I always say this, always, when you're going to test these cars, don't be too fast to start it up. Whether you're doing monitor testing for CAT, air fuel sensors, secondary air, EVAP, doesn't matter. There's certain PIDs you want to look at when the car has been sitting. In this example, this happens to be Global OBD2 for a CAN vehicle, which means 2008 and newer. It has ambient air, and that's my clue right there, that it's a CAN vehicle. It has intake air, it has coolant. And this car is cold, it's been sitting a while, and if you notice, all three are almost spot on, and you check your ambient temperature to this. If they're close to that, you know all three are in calibration. That's what the PCM is using to start its table lookup. The next one on the list is the barometric pressure sensor. Always check that and know what your normal reading is in your area. Know what your scan tool does and how it presents it. PSI, inches of water, inches of mercury, kilopascals. If you see 101 kilopascals, you know you're right down at the sea, and you're not down in Death Valley, you're not at 1,000 feet. But it is the one item that is what we call it has no rationality for the DTC. It's either open or shorted that it sets a code, but anything in between the computer uses. And if the inches of mercury drop below about 25, the monitors will be suspended. So always check the barometric pressure. Now I also know this is a CAN car because it has fuel level. And if you have fuel level, then you definitely are on a CAN car. Prior to CAN, you either had to use most cars, you either had to go into the OE side to find the fuel level, maybe in the body control module, or you looked at the dash and hoped that the gauge was right. So it's important that we get an accurate read on that, and we'll show that as we go along the way. Warm-up cycles, I only use that. It's not important to run the monitor test for EVAP, but what it is important for is to know if somebody's been in there messing with the car before you got it. If this car came into your shop that day with only one warm-up cycle, that means somebody duped you and cleared the memory before they brought it into you. Or maybe they just put a new battery in it. So it's not bad to take a look at that. If I see 10, 20, 255, which is the highest binary number, I know that someone hasn't touched that system in a long time. So as I receive it, is the way the customer's probably been driving it. Control module voltage, always check that, because especially with EVAP, with your systems that are key off, they require good battery voltage, a good state of charge for the battery to be able to run this test, because some of them can take up to 45 minutes to run once they go engine off and they open up part of the PCM memory to run the test. So a marginal battery could be a reason why you're not getting tests to run. Pay attention to that. And the last one I look at, and I know it's a CAN car because EVAP vapor pressure's on there. For numerous reasons I look at it. In the last class, I believe I showed a case where, the pressure sensor was actually the blocker to running all the monitor tests except for EGR. Always look at that. If you don't know it, go find it. And the other problem with global OBD2 is it's in pascals, which means that's a way we don't normally think. So here it says 81 pascals. If you times it times 0.001, it gives you the actual kilopascals. And if you look at my chart, kilopascals means there's almost no vacuum in the tank, and we are basically near atmospheric pressure. So if you need any help with that, just pick up your phone, Google, hey, convert pascals to kilopascals, convert pascals to inches of water, and whatever unit value you're familiar with, you will get. The issue here is that each scan tool shows it a different way. I see PSI, I see pascals, I see kilopascals, I see millimeters of mercury, I see millibars. So that's our problem, is not so much that we can't understand it, it's how they present it to us, and when we're not familiar with it, it can throw us a curve. So please do a pre-check. Again, this was a CAN car. In some cases, you might even need to go over and get your PIDs on the OE side. The PIDs I showed you on the last page, if it's a CAN car, they will be there. But let's say you go back to a car that's prior to CAN 2008, and you're going backwards in time and you want to do these PIDs. You might need to go over to the OE side for what you can't find on the global side. If you notice on this one, I have so far, I have baro, I have ECT, I have intake air, I have fuel tank level precisely, I have my fuel tank pressure in inches of water, I also have my voltage. I might want that detail a little more specific, especially if I see that my fuel tank pressure sensor is skewed. I want to go see what the voltage is. So over on the right hand side, we can see we got 29.8, 64, 68. We got a cold startup at sea level, and we got fuel level that's borderline but should be okay. We've got tank pressure that's very close to atmospheric, and we got a voltage on this GM that happens to be right around 1.5 volts. That's atmospheric pressure. So real quick, global OE, you might have to go both ways. The opportunity to look at that is there. Okay, and here's the enhanced side. Another look at the enhanced side, because if you notice on this previous page, I didn't get the vent solenoid. Global OBD2 does not give you the vent solenoid. Why they didn't include that is beyond me, but that would have been a wonderful PID to add to global OBD2 with CAN. So I can see that it's venting, which means it's open to the atmosphere, or I can see it's not venting. We'll look at this as we go along. EVAP purge, that's on CAN cars and OE cars. Pre-CAN, you won't see purge. Fuel tank in inches of water, again, pre-CAN, you won't see it. CAN, you will see a reading, but in this case, you saw it said pascals. Learn the differences between the two. There's a conversion to the voltage. You can see on this page, there's your percentage of fuel and your fuel level. So you're going to have to, again, as I mentioned earlier, sometimes use both sides of the tool. Now, I threw this up for the sense that lets you know that EVAP has a lot of different tests that it runs. And some of you might be familiar with mode 6, some of you may not. I don't use mode 6 necessarily for specific numbers. I use them to see which test may have failed or which test may have not run. If this was the monitor class, I would tell you if you scan the O2s in mode 6, you should never see zeros. 0, 0, 0. You should never see that. Unfortunately, or fortunately, in EVAP, you need to pay attention to that because you will see zeros because EVAP has what we call follow-up tests. So if you take a look right here, it says excess vacuum limit. It has a reading. That test has run, and because of the number range, it is passed. But if it was continuing to draw a vacuum on the tank, and the computer saw that, it would now do what they call a purge stuck open limit test. But since it passed this test, it doesn't need to do this test. So it's 0, 0, 0. Simple as that, but it's a follow-up test. Now down here, we're going to talk about key off system with positive pressure and negative pressure. Well, this vehicle happened to run and test under positive pressure. So that means immediately after shutdown, the pressure was high enough to know that there was no leak in the system. If it had been too cool, but it had raised up, but it had not been too cool, then it would have skipped this test, and over a period of time with the engine off, if it wasn't interrupted, it would run a negative vacuum test, and this would be populated, and this would be zeros. So if you're ever looking at EVAP and you see zeros, pay attention, it's probably a follow-up test. Okay, and this last one says blocked EVAP line. Well, that test passed. If it failed and they need to do a confirmation test, then they would run this test. So again, There's the primary test and there's a secondary test. If the primary test passes, the secondary test is not needed. So you look at mode 6, don't freak out if you see zeros in mode 6 for EVAP. Now, when you run EVAP monitors, monitor tests, there's two systems out there that we can focus on. The word series means like an electrical circuit. Everything has to work in order to complete the circuit back to its source. If it's interrupted anywhere along the way, you stop, you got to fix it to complete the circuit. Well, think of this. When you're running vacuum decay EVAP monitor, what's happening here is you are going from running the gross leak test, which I don't like that word, but let's say the large leak test, to the small leak, to the very small leak, to the excess vacuum in that order. It's a sequence. If it's interrupted anywhere and you've only run the gross leak test and then you change your driving habits or shut the car off, you ran one of the tests, but you didn't complete them all. And if you ever check this, you'll see that that first one runs a lot when the engine's cold. As the day warms up and you drive it more, it won't run anymore that day. But if it gets interrupted anywhere, it's got to start the whole sequence all over again. EVAP is a series monitor. We either do them all in one key cycle or we don't. And we start fresh each time, even though there may be numbers stored in mode 6. Now, if we go over to the other side, called vacuum decay with engine off, most of them only do the gross leak with the engine running. I have seen some earlier ones where they did the small leak, the 40,000 of an inch, with the car running. Then they do a recovery to see that there's no restriction in the system. Then you turn the key off. Then it sits there, and think of like a gallon of gas sitting in the sun, sealed up. It's going to expand, it's going to contract. Well, that's what's happening with your gas tank when you shut it off. And typically what you're running there is the very small leak, but in some applications, if the very small leak, they basically run the small leak at the same time. Now, the last thing I'm going to show you here, purge monitor flow can be measured before these tests start or after these tests start. And I'll show you those examples as we go through this. So keep that in mind. I didn't explain parallel, but parallel basically means for you out there who ever seen the catalytic converter run complete before the O2 completed, that's what we call a parallel monitor. 99% of my time doing this, every time the cat has run first, 99% of the time, the O2 will finish second. That's a whole explanation of that, but the point being here is we're dealing with series monitors, which means we've got to run them all for the flag to flip to complete. Okay, typical time frames when the large leak is running, it only takes about 7 to 11 seconds when the initial conditions are set up. It doesn't measure this over long periods of time. Now, it may take longer if it's failing. The pull down time can also be affected by fuel level and temperature. So it looks at how much air is in the tank, looks at the volatility of it, and it could take longer or shorter depending on how much fuel is in the tank. The small leak test, typically between 10 and 20 seconds. Again, longer if it's failing. And I'll show you examples of these as we get along. Okay, let's get into the General Motors system now. This is not a GM class. The two classes, I had so much information, that's why I decided to do a part 2 in the October class, excuse me. GM had two systems basically, vacuum decay system, which we most common thing out there, and vacuum decay with EONV, engine off natural vacuum. So basically they're going to check for large leaks with the car running, and then when you shut it off on the 2003 and newer, roughly in there, they're going to test the small leak with the engine off. But prior to that, they did everything in the one key cycle, which I'll be showing you here in a little bit. Drive cycles, they're wonderful. I tell you to stay away from them. I have these on my website. We started using these initially. The problem is, if you're not perfect or things don't go as expected, people don't know what to do. What I try and do is I try and tell you what you're doing at each point. And can you run these out of sequence? Absolutely, you can run them out of sequence. But let's just say on this vehicle, part of EVAP is testing right up in here, right up in this area here. So we would go look at the instructions, and here's an early EVAP system. Let's go through this one, and you can see it running on this Astrovan. It's a very simple system. I got it some fly-ins, so you can see your temperatures are normal, well within range. Okay, so we're going to let this vehicle run a little bit. This is the only part that's not real time. I'm going to jump ahead to the actual time that the tests start running, and once you see that, that's real time, so you can get an idea. It's very quick. So the purge is off, the vent is open, you have a little bit of pressure in the tank, but not much, minimal. Now, when this gets to 140, things start to happen. The purge is on, Duty cycle's up and the vent is closed. When it gets the right conditions, there we are. Don't look at the on here. The purge is open. That says on. Oh, excuse me, says on. We're going to see off in a little bit. 12% close. That means we're pulling this down right here in about 10 inches of water column. You notice that test is passed. And notice what it says. It says weak vacuum. If you're doing EVAP, don't think of gross leak, because if you do, the first thing that's going to come out is your smoke machine. Weak vacuum means the fuel tank pressure sensor did not see what it expected to see. The purge may have not opened. There could have been a restriction in the line. So you need to also think about those things. So weak vacuum to the pressure sensor. Pressure sensor could have been bad. It could have been skewed. Okay, now we've done the gross leak, the large leak, weak vacuum test. Now we're going to move on to the small leak. And think of that as put a tourniquet on your forearm and holding the blood in your hand and your forearm. If you hold it there long enough, one, it might go a little numb, but you're going to feel it start to throb. You're going to feel that pressure build up a little bit in there. If you had a leak and blood wasn't squirting out, that would be your small leak. Well, that's kind of what we're doing to a fuel tank. We want a little pressure to build up, but we don't want it to rise fast. So here we go. Let's take a look at that again. Let me pull that forward. Sorry, got a little ahead of myself there. Let me get back to where we need to be. And we should start running the test right about, there we go. Okay, this is where I was. Now take a look at this. Watch the vent. The vent is the key. That's why I wish the PID was on Global Scan Tool. We're now running the weak vacuum check. I'm backtracking a little bit so you can see how quickly the large leak test takes passed. Now we're going to close both solenoids. Now notice this says on, but 0 duty cycle. So that means it's off. It's closed. The system is sealed. It's holding pressure right here. The number drops a little bit because there's your arm starting to throb. If it was a big leak, that number would drop fast, and I'm going to show you that in another video. Okay, both solenoids are closed. Notice light vacuum decay towards pressure. That's normal. That test passed on this car. Now we got to do is we got to vent it out, make sure that we don't have any solenoids stuck. We don't have any lines restricted. So now we're going to open the system up and look what we call for excess vacuum. You might hear a P0446, vent solenoid stuck, something like that, or FTP could be stuck. Something is not showing that the pressure is leaving. So it's like opening the front door and opening the back door in a house and letting a breeze blow through to bring your temperature down to normal. That's what we're doing in a gas tank. So very shortly here, you're going to see that this test passed. All this is real time other than where I stopped it. This is not taking very long, all things considered. Okay, so now we're venting the system out, creating a draft through the system, trying to get it to go back to normal values. Okay, there we go. We have no restrictions right now. Now we want to check the purge solenoid. We're going to do this one afterwards. Now notice, I'm going to stop that a second. It says it's closed. It's closed. That says on, but this is the system is sealed. 1.05. Watch what happens over the next couple frames. You're going to see it going up. It's a sealed container. If it's a sealed container and it's running, there's going to be pressure temperature buildup in there. And right there, it's built up pressure. If the purge was leaking, it would draw a vacuum on the tank, and this would go down to the minus category. So that's how it's checking purge flow here. Some manufacturers do it a little differently, but that's one of the ways we're doing it. So let me finish this one up. All of them are done. EVAP test is going to pass and fail. Pass right here. Testing is done. I go to my EVAP page or my readiness page, and my EVAP monitor test is done. So when you take the time to think this out, you'll find out that EVAP can be run. It's just that it doesn't finish in some cases. Okay, here's a graph from Snap-on Scan Tool into their PC-based shop stream, just to show you. This car, there was purge check here. Basically, you shut it down. You look for any changes in the pressure sensor at this point. You notice the pressure sensor is steady. Because it's steady, the purge is closed. It knows it's not leaking. Then we do the weak vacuum I just showed you. The vent is on this whole time. And GM does have a tendency to flicker it a little bit, but everybody else leaves it on. Most people don't even catch that flicker. Very small leak test here. And then we vent it out, and there's your recovery. And if all is good, we're done with our test right here. Now, here's the purge in a different view. If you notice, the purge is off. Nothing's flowing through it by the off command. Could be, but there isn't. Because if you notice, the tank pressure is it's in a pressure, so it's building up ever so slightly, which means there's not a leak. It's not being drawn. If that line went down like this, that would tell you that the purge were leaking and it's time to replace it. Some granulated charcoal in there, a plunger that's stuck, whatever it might be, it's letting you know that you got an issue there. Okay, so that's how we get through that first test. And again, just to review here, we're going to go now. GM had a second system called EONV. We're still going to use a vent solenoid, but on the EONV, as I showed you earlier, it only does the large leak and only does a recovery. So I've noticed the purge is never closed here. It is always open. The tank pressure is rising. That tells us that in this case, I should say the pressure is dropping, but it's a GM, so the voltage is rising. That's letting us know that we hit our target vacuum we want it to hit in the right amount of time to say that there's no gross leak and there's not a weak vacuum to the tank, to the pressure sensor. Once we do that, we turn things, leave the purge going, and we go ahead and let the pressure sensor relieve itself back. You can see it drops in the duty cycle, and the pressure begins to equalize. We'll look at the after effect of that later on with the small leak. Now this was a service bay test in the same car. What I want you to see here is know the scan tool, know if you have the capability of testing running the test in your bay. Now when you run a service bay test, we'll talk about this in the next class, but some of these won't set the flag. Some of them will set a DTC for this test, but they won't put it in memory because it was just a service bay test. And sometimes on these, we'll talk next class with Honda especially, where Honda and Ford, they run service bay tests, but in reality, you got to be careful. They don't run the small leak test in the bay. But this one is just a conventional purge and vent, and it's going to run the test. So watch this one here. And I picked these kind of vehicles because you can see on the scan tool, it shows you what's going on. Sorry, it's a little grainy. I got it off of an old Tech 2 using an old analog camera. We didn't have digitals back then, but it's so good. I just don't stop using this because it shows me what I need. So look in the car that you're working on and see if there's an EVAP test or service bay test. That's what you're looking at. And a number of them have it. I can think of Hyundai. I can think of Toyota. I can go down the list. A lot of them have service bay tests. So you can test it without driving it. So we're going to let this run. Key on, and engine's off right now. We're getting everything prepared. It says turn the ignition on. Now it says start the car. So you'll see in a second here what's on the screen and how that works. So in this case, in this particular one, you might have some cars that will idle up for you, but in this particular car, it was not a drive-by-wire and it did not idle up for you. So you had to open the throttle to get the vacuum into the system to be able to test it. Now it says it's waiting for purge enable. That means this engine is probably below 140 degrees. It's waiting for the 140 degree temp to begin to make things happen up here, and I'll show you when it does. Okay, you can see the vent is open, no duty cycle. You're at just a little bit of pressure here, minuscule. Now notice, purge is open, vent is closed. Watch how this draws down. We're doing the gross leak or weak vacuum test right now. So we watch it. It's pulling down, just like we saw in the other earlier. And watch the judgment by the PCM here in just a few seconds. Now again, the time to run this test depends on how much fuel's in the tank. Lower means longer. Okay, so it passed that one. Now watch a small leak. Everything is closed. Look at what's happening, and I'll show you in a graph how this looks. Notice how the pressure is rising very rapidly. We're losing our vacuum. Now the PCM says, hey, there's something wrong here, so watch what it does. I told you earlier, some of these tests will run a couple times. Watch this one now. Now we're doing the weak vacuum gross leak test. You see it ramping back up to show there's no gross leak. Now it's going to try and, very soon, it's going to close everything, put a tourniquet on your forearm, and see if you can keep the pressure in your arm. So give it a second here. You'll see it kind of flicker. There you go. Now watch. All of a sudden, there's nothing staying in there. That bike tire's got a big hole in it, not a small, not just a leaky valve. It's dripping down slow enough, fast enough. You may only get a few blocks. Think of it that way. Okay, so here we are. We got two fails right here. PCM says, okay, let's try it one more time so we can be sure that we know that there's really a problem. So here we go. Large leak again. Watch for the flicker. That'll tell you that the large leak is done. Okay, well, there we go. There's a flicker. Now watch it drop fast. That would be a small leak in this system. Now we might want to do our visual inspection and get our smoke machine out and go find out where. Now I'm going to pull this forward a little bit for the sake of time. And I'm going to show you that the purge, no, we're not going to do the purge on this one, excuse me. We're going to go ahead, we're going to go by that because it doesn't run the purge because it already saw it fail. So in the end, what we got on this car was basically a 442 small leak. So this is the PCM in control of the testing, and some of them do it even better than this, but I just want to show you the simple way. Okay, and this is what that car looked like. If it was a good system, you notice this is the vacuum. It's been pulled down to this level. Now you seal it, and it starts to build up a slight pressure change, losing a little bit of vacuum. There's flat line, there's the increase. That's normal. This is that system with a small leak. Notice what happens. See how it goes up, 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 and that's the one you just saw. That's that other one grafted into this picture. Okay? So that's what a small leak would look like on a car if you were to graft it out. Okay, so here's our, watch this one now. This is the General Motors key off system. Basically what it's going to do is it's going to wait until the engine shuts off, but it's going to run its gross leak weak vacuum test now. Now notice I checked the temperature. Temperatures are within range. I've already been running this vehicle. I know the barrel is good. I know my fuel level is good. Notice we're going to see venting, purge solenoid, and then we're going to focus on our pressure reading. So let's go ahead and run this and watch this happen. It's going to speed up fast because I recorded this from Autel, and for the sake of time, I played the recording back quickly. So notice, temperature's cold, vehicle speed's picking up, system's still venting, and the purge is off. I just keep watching. Purge is not enabled yet. It's still too cold. So here we are. So let's see when the purge kicks in. 120, 125, 32. Whoops, darn it. Let me pull it forward again. Sorry about that. It's my fault. Okay, there's the purge right coming in right over there at about 135 degrees, 134 degrees. So now we're about ready to let the system roll. Now watch at 140. Look at what happens. Not venting. That means it was drawing the system down. Okay, keep watching. That quick. It drew it down, knows what it's looking at, sees the pressure increase, and the system's on its way. But remember, the purge doesn't close because this is an engine off system. So we don't lock both solenoids. Okay. And here's an example of a key off system. This is from a GM. We're focused on GM right now. Notice what it says. This one started the testing about 5 minutes after shutdown. You take the key, you get out of the car, you walk away. You don't even realize it. You just drove it for almost over 28 minutes. That helped build up some pressure in the tank. The computer looks at that. After so much time, it turns the system on. Eventually what it does right here, it turned the vent on. So now it's sealing the system. The purge is closed. And the system has obviously got pressure in it because if you notice, the pressure is going up, 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 up. This is your gas tank, sealed, sitting in the sun on a hot day. It went from cold to hot, and the tank is expanding. If we can hit 1 inch of water column or higher in the time specified here, then it knows it doesn't have a leak. This is the positive side or the pressure side of the test. It knows it can go ahead and pass that test. And since this is the GM, this is the only car that does this, and I like to show that. GM is the only one that starts at 1.5 volts. Anything down low is a pressure. Anything up high is a vacuum. So if you notice, you have high pressure right here, about 1.23 inches of water column, but you have a voltage over here that's 1.2 volts. It's a flip-flop from what is normal, but everything on this picture is working the way it should. But this would be happening to key off system. And here's a little suggestion, especially on GMs. If you've driven enough, leave your scan tool hooked up on the OE side, go into the EVAP page, and pull up the PIDs that you want. Leave them there, shut the car off, take the key out. You'll see the scan tool say no data. Basically, your computer's gone to sleep. When it begins this test, say at 5 minutes on this car, you will see the scan tool come alive. That's how I got this data. So that data is broadcast to the scan tool so I can see these test results. Not all manufacturers do that. And the thing is, sometimes you got to wait a long time. I take my top down and I put them on record and just let it sit with the engine off and hope that I catch it. But that's a tough one to do. So this is the positive phase. This is how a key-off system works. Key-off systems have been around since 2003, heavily since 2005. The problem was when small leaks were not being checked effectively with the car running. Too many variables. So what they said is, let's use the principles of gasoline in a sealed container, or liquid in a sealed container, affected by temperature. So that's what EONV is. It's the same as your standard vacuum decay, but it tests when the engine shuts off. That can be anywhere from, I've seen 5 minutes to as long as 45 minutes. And if the pressure isn't high enough, it could take much longer to cool into a vacuum. That's GM used to say it could take 7 days to do the key-off system. Chrysler used to say it'd take 1,080 minutes for the system to completely test. You're not going to sit around waiting for that. You're going to shut the car off and hope that it works. But that's just to give you an idea what it can take. Here's some basic criteria I pulled up. What you're going to find is most of these need, on average, about 15 to 20 miles of driving. I've seen it in miles, from 8 to 10 miles. The idea is if you're driving, the fuel is building, tank is building pressure. If it's building pressure, now we're going to be able to test it. We're going to test it in pressure, we're going to test it in vacuum. So specifically, you'd have to look at each manufacturer, but unfortunately, many of them do a poor job of giving you these specs. Just know how it works, and you got to be patient. This is why EVAP doesn't complete. Those other tests I showed you for gross leak stuff, purge, those work. Those complete most of the time. It's this test with the engine off that can be interrupted, and there's more variables to getting this to run. So that's why we don't complete the EVAP test as often as we should. And here's some more information on codes, but there's our 1 inch of water column. If we can get 1 inch of water column or higher, that means that system's got enough pressure to test, and we can work from there. If it's too high, it's going to suspend it and let it cool, check it again, check it again, check it again. That's why we need a good battery, and that's why it can take time to do it. Okay, so here's the one I showed you earlier. Again, I'm just going to blow this one up. We got the vent on. We're pulling the purge through the system. We're pulling down to our gross leak level. We're good. Move on. That test is done. Now what we want, and I blew this one up just so you can see it even better. Vent on. Purge is flowing. Pressure's decreasing. Voltage is increasing on this GM, which other cars, this line would be parallel to that line and be going down like that. But you need to understand the variations out there. Okay? What you're trying to do is build up enough pressure to get into this range to know that the system is okay. It's got to get to a certain level. If it gets to too high a level, it's too volatile, it's not going to test. If it doesn't get to a high enough level, it's going to cool in the vacuum. So let's say we get to a system where there's pressure, enough pressure to test. What that would look like is similar to what I just showed you earlier. The vent is on, the engine is off. If I showed you the RPM pit on this one, you would see the engine is off. While it's sitting there, it's expanding because it's a sealed system. Purge is closed, vent is closed, and that's our 1.23 inches of water column that I showed you earlier. Now, let's say this thing only tops out at maybe a half an inch of water column. There's pressure, but there's not enough to test. So what will happen then is the computer will look and say, hey, there's pressure there, vacuum/pressure there. It's not high enough to test, but it's enough that we can let it sit and cool and see what it does. So here we go. We let it sit and cool. If we can pull it down below 1 inch of water column, again, that system's going to pass. If we it cools down, but it stays above that 1 inch of water column, it's going to fail for a small leak. So it's an either-or scenario. The way that would look is, here you go. Here's where the purge turns on with the engine off. You can see there's some pressure in there, minuscule amount, but there's enough. So we let it sit, and cool. Cool until we get down here to a little over 1 inch of water column, and now the system is done, but we tested it under a vacuum rather than a pressure. Okay, so those are the two scenarios we can do. Now let's finish up today. We should be dead on with time-wise. If you're working with Nissan, I love Nissan EVAP systems. The first one was a little hairy from 96 to 2002. It was more the way they ran their monitor tests than anything. But basically they use what they call a pressure system. And I'll show you that. A system tested under pressure, not vacuum. Starting in 2003, and there was overlap into 2002 and some into 4, but 3 was the average year, they began to test the system for vacuum decay. Then in 2006, they started rolling out EONB, engine off system, and that's still used to this day. And not much has changed there. So let's go through their system. The 96 to and this one 96 to 98, 99, right in there. They use this basically the same components. They use a purge control solenoid, duty cycle. They use a pressure sensor. They use canister, vent, a water separator for the inlet. They use a vacuum cut solenoid for this solenoid right here called a vacuum cut valve. And on these earlier ones, I'll show you on the next one, the 96, 98s, this was actually a volume control stepper motor. So it was changing the flow of vapor into the engine, but it was doing it using a transducer and a solenoid. A little bit different how they work. The rest of the system worked the same way. And again, 96, 97, 98, kind of a freakish system in some ways for those that had it. Now, when you get into this valve, I showed you earlier, this one right here, I want you to look at this. This valve, that plastic valve I'm going to show you there, is saying that when we are under normal purge conditions, purge opens up, we draw the vapors out of the canister, the pressure sensor sees a little bit of vacuum, knowing there's flow. This thing becomes a restriction in the system, so you're not drawing from the tank. You're not sucking your tank down. Okay? What happens is when the monitor test goes to run, this solenoid is energized, and now you allow full vacuum to go back to the tank to quickly run your large leak test. And that valve typically is located in the right rear of the car, sometimes left rear. Plastic valve, 4 nipples on it, goes to a solenoid. And think of it this way, it basically kind of splits the system. When it's not in operation and it's off, it's normally closed. There's a little bit of leakage to the tank, but not enough to suck the tank down. Not enough to draw in a bunch of vapors from the tank, but enough to just balance the system. When you energize it, it opens up and allows engine vacuum to reach the tank to run your large leak test. Again, lots of Nissans still out there, especially on the west out here, that have this system. The plastic lines do break over time if you're not careful, so be careful when you're working with these. They get brittle over time because they're in the back. The exhaust is in the area. Depending on the environment you're on, they can get hot. Okay, now here's the key to Nissan. That's why I like running Nissan all day. They use a fuel tank temperature sensor. Remember I said earlier, EVAP is very sensitive in running based on temperature. So Nissan said, we're going to put a temperature sensor in the tank to see what the temperature is, which is a reflection of pressure. And when we know the temperature, we know when to run the test. And I'll show you in a video in a minute. If you're driving the car and you're building up pressure in the tank, if we get a 4 degrees rise in the tank, that is part of the criteria for the EVAP, the PCM to say, run the EVAP test. Not all of it, but it's a big part of it. So the problem with this is the PID is only on the OEM side of the tool. So if you're doing Nissan, you can do your preliminary checks on one side, but you got to get into the OE side. This PID will be on all of them. Built in the tank, there's even a bi-directional test for that where you can control it and vary the resistance in the circuit to see if the sensor is there and it's working. Now, what does that look like? Again, captured from Snap-on. You notice when we turned the key on, it was 53 degrees. We're warming the engine up. We're warming the tank up. All of a sudden, the purge is working here. We're driving the car. Normal purge, steady throttle. Then all of a sudden, we get to 57 degrees over here. We're at a steady throttle. Notice what happens. The purge really ramps up. The vacuum decreases, and Nissan uses voltage, not pressure. When I see a Nissan go under 4 volts, I know we are doing the large leak test. This is the large leak test right here, but it would not run until this had reached 4 degree rise. In this case, 57 degrees. So if you're trying to do a Nissan on a cold day, you want to slosh that tank. If you can just jimmy jack that car on and off get that tank sloshing and see if the temperature is going up, then steady the throttle, you can get that thing to run. And I can run an EVAP monitor on a Nissan multiple times in a day just by watching the temperature. I don't need a cold startup to run those cars. This is the pattern they used on the early years, 98 to about 2002. This is all the CAT, the O2, getting the EVAP ready, but what they wanted you to do was come to a stop and then accelerate, decelerate, so slosh the tank. By sloshing the tank, you're building up pressure in the tank because the early system is going to test for pressure, not vacuum, and I'll show that to you in a second. Here's the verbiage that goes with that pattern. It says, depending on the fuel tank temperature's increase, the EVAP monitor might run after a decel. If it's gotten hot enough while you're cruising, it may not need a decel. It needs pressure expansion to test. And down here is a little bit more explanation on EVAP if you need to run one. And these are on my website. Okay? And then here, you've got a early generation Nissan. Sorry about that. Someone came to the door. My dog's going nuts. This is the early generation. The 2002 and earlier. If you notice, if this was at sea level, you would see 3.4 volts. Now, what does that mean? That means this is a split system and has one of those vacuum control valves in the middle of the system. That's this right here. So that means I got a split system. Then in 2003, I'm just giving you a break point. You'll know the difference between the two by looking at the voltage on the sensor. If you're at sea level and you see 4.1 volt, then you know that you are at sea level on type 2 system. It's a higher voltage. And basically what they did in that new system is they removed that restriction to the tank. They run the system as one. They no longer need that. Okay, and here's the breakdown. Just a schematic if you're working on Nissan to see how it's set up. And this is almost every Nissan. This is every Nissan I can think of since 2004. Take it to the bank. They all have pressure sensors and temperature sensors, and the temperature sensor is the key to running it. So to finish this up, let's take a look at the first generation. This is the first generation that has the split system. Notice, there's my pressure. It's in this car right now, 3.8 volts. The purge is closed. It has a vacuum cut valve, which means it's a split system. So when things start to happen, we're going to look down here. More importantly, when this system tests, the purge will be closed, the system will be closed, and it will be looking at the voltage here going up. So let's run this for a little bit. You can hear the dyno in the background. The temperature, I wasn't focusing on this one, but it had gone up. I'm driving it some more. It may go up a little more. I forgot whether it does or not, but keep watching. Notice this is normally 3.4 volts. We're down to 3.2 volts. So we are drawing on the tank right now because the purge is open. Okay? So just keep watching. The key is watch these right here. Watch these two, or these three. This will be 0, this will be on, this will be on. That's when the monitor test runs. And this number is going to go up. So let it go, let it go. So you got this and one more video, and that'll about wrap us up. So we should be right around time for the hour. I know some of you got to get back to work. Also, this is recorded. They're supposed to send you a link out so you can look at it again. Okay, so normal purge, driving down the road, we're at 3.3 volts. Temp sensor, I believe, has already gone up as much as we're going to get. But let me take a look. For the sake of time, let me speed this up a little bit. It's the beauty of video animation. Okay, there we go. This one does go up 2 degrees. Nothing's been happening because look at 20 degrees. Now watch when we get this to 21 degrees. Let me get this to 21. Come on. I'm going slow, so I don't. There we go. Now there's the 21 degrees. So we went up 2 degrees Celsius, 4 degrees Fahrenheit. Now watch this. Watch this close. These go on. And what you're doing is sealing the fuel tank. Now the system is testing under pressure, not vacuum. It's looking for expansion in the tank. It's looking for expansion. And notice the voltage went all the way up to 3.76 volts. 3.4 was normal. Below that was vacuum. Now it's under pressure test is done. This was a normal one on your 98, really the best one, really 96 to 2002s. This is the way I was running. But if you notice, the key was that temperature in the tank. Nothing happened until we rose that temperature. So when you try and do a Nissan, they do run and they run well, but you got to get the tank temperature up. So let's take a look at this one that has a fail in it. And this one is a no split system. It's using engine vacuum to test the entire system. So watch this. No vacuum. I hit the wrong one. Yeah, I did it. There we go. That's the right one. Let me, hold on a second. My fault. There we go. Incomplete. Let me drag it along for the sake of time. Okay. Now notice, no vacuum cut valve down here. There's our temperature. You're not going to see much on this one. It was already warm when I started recording this. There's the 4 volts, so you know this is one system. It's not split. Normal would be 4.1. The purge is open, so that's going to pull down a little bit. Watch for this to come on. The key to this is watch the vent come on. Then you'll see this pull down, and this will still be open. For you guys that have dynos, you can put the car in the dyno. You don't even need to put a load on it. Just spin the wheels. And I'm letting this run a little bit because this has a failure in it. I want you to see it. Okay, now notice, purge is off, voltage went back up. So if that voltage went back up, that's telling the computer that the purge valve is sealing and it's not pulling into a vacuum. So it's just testing the purge there. So let's go ahead and let's keep watching. On, right here. Okay, so now we are pulling a vacuum like I showed you on the GM. We're pulling a vacuum on the system. Watch this drop, voltage drop. Keep watching it. Whoops, darn it, I did it again. I'm sorry. I'm looking at the screen trying to talk to you. I'm going to pull this forward. Stay with me. I'll get it right there, right about 3.96 volts. That should do it. We'll go back just a second here. There we are. Now watch. This is off, this is closed. Watch how fast that's going up. That's going to go up to 4.1 volts. That's telling the computer there's a leak in the system, a small leak. Now it's going to try it again. See if this goes on again. Always, that's why I wish the vent was a PID on a scan tool. There it is, it's on again. Okay, it wants to see that the system, now it wants to see if it can build pressure since the system's sealed. It's not building pressure, so in this case, it's saying, hey, we got a small leak. So think about what I just said. The first test was seeing if we could pull a vacuum. We did pull a vacuum. We sealed the system up. The pressure, the voltage went right back up. So the second time it says, okay, let's do this. Let's seal the system and see if the voltage will go up, because if it's sealed and we're running the car, the voltage should go up. It didn't do it on either one, vacuum or pressure, so it knows it has a small leak. So that's how Nissan tests. So if you work on Nissans, let's see, let me go into here and show you what it came up with. If you work on Nissans, also find some of this information in your enhanced scan tools. I'll show you that in the next class, what you can do in the service bay with some of these. Okay? There's your small leak. So basically, when it was pulling it down, it did what it was supposed to do. When it sealed the system, it was leaking, and the voltage went up. Then it tried it again and said, okay, this time I'm going to seal the system and see if it builds pressure. It couldn't do vacuum. It couldn't do pressure. It knows it's got a small leak. And that's how we do the Nissans. As I said, Nissans to me are pretty cool. Okay. For you guys, if any other Tech Tip Thursdays, this is the QR code for registering for Tech Tip Thursdays. And for you guys that don't know me, here's my information. You can reach out to me if you have any questions. There's my Gmail. There's my website. I'm here as a resource for you guys. I love doing these. Next month, we're going to do part 2. We're going to look at Toyotas, which are a number of systems. We're going to look at Hondas, look at Ford, and we're going to look at LDPs. And we're thinking about doing, there might be a fourth one in the series of EVAP in November. So I've got a number of other things that we could put in this, and these 4 classes would give you a very comprehensive look at EVAP. And hopefully in the next couple of months, I'll support this with more information on my website too. So for all of you in attendance, thank you. The Delphi will send out a link to this class. So you'll have a webinar link to look at if you want to review this. Hopefully you found it helpful. If you want any feedback or give any feedback or comments or questions, shoot them off to my email, since this isn't really a open forum Zoom meeting, even though I'd like to have it that way. So anything I can offer you, I'm here. I hope this enlightened you on a couple systems today and some EVAP do's and don'ts. Next time we'll pick up with some more systems, because EVAP monitor tests do run. What happens is they just don't finish sometimes because they get interrupted. Okay? So that being said, we're done for today. Look for a link. I know it takes a few days for them to render the recording and get it into your email. If you don't get it, reach out to me. Use my email and reach out to me, and I'll make sure you get something for today to know exactly what went on. Other than that, I thank you, and I have a great day, and hopefully we'll see you on October 23rd for the part 2. Take care.